Okay, so back to our alloy. So again, the alloy, if you've seen it, it's very dirty, especially when there's a rain. Oh, it looks like a nasty version of chocolate milk. You can't even see like an inch into the alloy when that happens. So what should you do if you fall in here? Say you're paddling and then your canoe hoolies and you tip over and you end up swimming. Well, first thing you should do, don't open your mouth. You don't want to swallow that water again. The bacterial counts are way above the safe limit, so you're going to be swallowing all this bacteria. Yes, you have that stomach acid, but in case there's a bacteria that are resistant to stomach acid, again, you have these innate defenses, but they have a limited capacity as well. And don't touch your face. Again, after you get out when you swim to shore, you don't want to introduce the bacteria that's on your skin. So again, if your skin is intact, this is why you don't want to touch your face. Again, where are portals into the inside of your body? Again, nose, mouth, and even your eyes. So again, don't rub your eyes too much. Then wash and shower off. Again, just wash with soap. Shower off, wipe all that bacteria and pathogens off your body. And don't paddle if you have any open sores and cuts. And why? Again, your skin is a big barrier against pathogens. So if you have open sore and cuts, that's an easy free passage of these pathogens inside your body. So again, and where does this sound very familiar? Again, coronavirus prevention. So again, this is just generally good at preventing any pathogen for entering your body. So again, what happens if pathogens can enter an open wound? Say it's a bacteria, or so this is how your body reacts. I love that scene. So you actually recruit your immune defenses, aka your leukocytes, so your white blood cells. This is how your body reacts when you have an invasion of a bacteria or pathogens. So leukocytes, these protect your body against pathogens. Yeah, I want to actually include the endgame portal scene, but yeah, copyright, and it was really hard to find a clip of that because you know how the mouse is very protective of their intellectual property. But anyway, so again, leukocytes, white blood cells, this protect your body against invaders. These are the protect your body against pathogens. So there's a broad term. So phagocytes, these are phagocytes, whatever. But these are cells. So the Greek root word phage, or actually I think it's actually pronounced something closer to phae. But this is the Greek word for eat. So when you see this brand of yogurt, it's literally eat yogurt. Yeah, it's calling, say if we had like our version of yogurt and we just called it food. But yeah, this is what it means. And then cyte again is means cells. So these are cells that eat. So any cells that can eat foreign pathogens or any foreign bodies, eat something from their external environment. They are phagocytes, phagocytes, whatever. So these are broad categories. So it's not just one specific type of cell. If a cell eats things from its external environment, it is a phagocyte. So things like trash and debris in the external environment, things like pathogens and bacteria and viruses, or even dead cells. So examples of these include neutrophils and macrophages. So we will cover those real quickly. So monocytes, so we did cover that when we talked about white blood cells and leukocytes a bit. So again, these are phagocytes. These are cells that eat, and these are highly mobile throughout your bloodstream and tissues. So they're actually always patrolling around through your body and looking for, in case like some pathogen enters your body at some point, then there's some monocyte typically already there or is eventually going to patrol there to encounter that bacterium or pathogen. So how do these monocytes know where to go? Well, there's a specific term or a specific process called chemotaxis. So chemo sounds like chemical, which is where it comes from. But taxis, so think of it, it looks like taxi, right? So taxis refers to movement. So it's movement due to chemicals. So chemotaxis is typically movement, or so it's any movement of a cell. So even your own cells can do chemotaxis, so can bacteria, but it's movement of any cell toward or sometimes away from a chemical. So either a cell smells, it's like a cell's sense of smell. It's either going to go toward a smell that's very interesting, or it's going to be repelled by something that they think is potentially harmful, and they'll move away. Either way, a chemical is telling a cell to somehow move away. How does it do that? Hey, remember that thing about ligands and receptors? So if a cell has a receptor to a chemical and it causes chemotaxis, hey, this cell is kind of like sniffing out that chemical. So bacteria and damaged cells, these release chemicals and proteins. So what happens if bacteria is there and it's releasing its own chemicals? Hey, your immune cells might want to have receptors that recognize these chemicals, and therefore it's kind of like the breadcrumb trail or some sort of scent trail where they can find the source of this bacterium or pathogen and follow these chemicals to the source of that infection. So immune cells detect these chemicals and go there via chemotaxis, especially cells that eat debris and pathogens, these phagocytes. So they're kind of like police dogs. What are they there for? Well, they sniff out chemicals, chemical traces of things that are dangerous. So if there's a danger, they help to lead the police, or in the airport, they help to lead those TSA agents to the site of a threat so they can neutralize that threat. So chemotaxis is kind of like your canine units that help to sniff out drugs or harmful explosives. Okay, so macrophages. Let's talk about that. So macro is the opposite of micro. So micro means small, right? So therefore macro means large, right? So these macrophages, these mature from monocytes. So again, macro means large, and these are also phagocytic. So that means that they are big eaters. So again, macrophage literally means big eater. So again, eat. So they're kind of like, this is what a macrophage is. It's part of your defense, but it's also a big eater. So what are they important for? They're also important for recruiting neutrophils and other immune cells. So they're kind of like this cop. If they see something, they're big eaters, but if they see some sort of danger, they're going to recruit other immune cells to help to fight that infection. And they also help to cause inflammation. So we'll cover inflammation very, very shortly. Alright, so free versus fixed macrophages. So again, they're big eaters, but in generally they behave in two different ways. These are free macrophages. These are ones that are actively patrolling, so they're like patrol cars or mobile squads. They're kind of roaming around your body, hoping to encounter some pathogen that happens to enter when they're in the vicinity. Now there are fixed macrophages, so things like the ones there are macrophages in your lungs, because again, your lungs are, the inside of your lungs are exposed to the external environment just through breathing. So it makes sense to have macrophages that are there just lying in wait to attack any pathogens that you happen to breathe in and make their way all the way into your alveoli. There are also macrophages, a lot of macrophages in your liver, and hopefully we have time this semester to cover the liver. But again, the liver, eventually all blood flows through the liver and filters through the liver, so it kind of makes sense to have macrophages at the liver so it's able to kind of like detect any pathogens that happen to be in your blood at the time and remove them from circulation. So they're kind of like campus police. So you notice that some campus police, they tend to roam around or patrol around, but some campus police, they're kind of like good just staying in one place and just hanging out and just like surveilling the area just by looking around. So this guy like here, say he just stands there, he would be a fixed macrophage. But these ones in their golf carts and segways, these are free macrophages. Alright, so how do phagocytes, we know they eat, but how exactly do these phagocytes eat? Well, here we have, say we have a pathogenic bacterium. So what they do is actually envelop the bacterium or pathogen in their own plasma membrane. This forms a little bubble inside the cell. So this is like their little mouth, and they're forming a little bubble. So this is what we call a phagocytic vesicle. So what happens? Well, eventually the cell mixes this enveloped pathogen with chemicals, so including enzymes, and also very acidic products. And this helps to digest and break apart this pathogen so that it neutralizes, kills the pathogen, and therefore it can eventually excrete it. So this is like the cell eating the pathogen, digesting it, and eventually coming out the other end as a dead pathogen. Alright, so spelling does count. Why? So phagocyte is a cell that eats. Phagocytosis, the process of how a phagocyte eats. So again, this does refer to cell eating. But are we talking about the cell itself, or are we talking about how the cell eats? So again, You are different from how you eat, right? So same with the phagocyte and phagocytosis. The macrophage is that big eater, but macrophage is a phagocyte. But they also release chemicals that attract neutrophils. So I talk about neutrophils a lot, but what do they specifically do?